Alright, welcome back to the YouTube channel. And today we're going to solve these questions. There are 4 questions. So I'm going to start from question 2 because question 1 is very simple. But for you guys who have subscribed to A+ Academy app, question 1 is there in the solved tutorial sheet. Okay, but like I want to focus on the important things which they might bring on the test. Okay, because the chances of bringing this on the test is quite rare. Yeah, but for you subscribed students, I've already taught these things. Okay, so I'm going to start from question 2 up to question 5. So I'll solve question 2, 3, 4, 5, maybe even 6, I don't know. Yeah, but between 5 and 6 I'll end somewhere. Yeah. Okay, so the purpose of this video is to just solve. Okay, I'll be solving the tutorial sheet. While solving, I'll be explaining. I'm not solving this video on YouTube right now. This is part 1 video. I'm only solving from question 2 to question 5 to 6. Okay, but for you guys who have A+ Academy app or have subscribed to our app where there are video lessons, 4 video lessons, you are going to access part 2. Part 2 video, I'm going to solve from question 7 to question 11. Okay, so make sure that you download the A+ Academy app. Okay, so this video on YouTube, I'll just solve from question 2 to question 5 or 6. Okay, I'll just see where I'll end from. Okay, and make sure that you pay attention because they might bring one of these questions in your either test or exam. Alright, so make sure that you are following along. And I repeat, this video is not for teaching purposes. If you are here blank, like you don't know anything, and you want to learn, like you want to start from scratch, you need to contact me so that you can access our full video lessons. There are video lessons which I record, which are focused on teaching you from 0 to hero. Okay, these are found on A+ Academy, where I start from the basics. I've taught all these things under functions, but for this video, I'm just solving. Alright, I'm just solving. I'll be using the knowledge and the concepts that I've already taught in my videos on the A+ Academy app. Right, so without any further ado, let's proceed and make sure that you get a pen and a paper so that you are following along. Okay, because some of you just like watching. Trust me, you find that maybe it will be boring because you'll be just seeing me solving and you might find yourself dozing. That's why the majority of you doze when you're watching videos. You even say videos are not for me unless reading, because you don't follow along, like you don't participate. So assume that I'm standing in front of you physically and I'm teaching you, I'm solving for you. Okay, so make sure that you participate. Alright, and before I even proceed, subscribe to the YouTube channel so that whenever I post a video like this, you are able to receive a notification so that you can watch it as soon as I upload any latest video on the YouTube channel. And share this video with your friends, okay, so that they can benefit. So let's proceed now. Plus, this is where you access all the full videos. So what you just do is come here on videos and then click on term 1, term 2 or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions. If you haven't understood everything that we've learned so far, or that we're going to cover in the video, okay, so all these topics, okay, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are. Then you will catch up at the end of the day. And we have a lot of students who are watching these videos and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. You're going to find videos about it. Okay, but it's not only math. Even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just use CH110. You find the videos here. Okay, if it's introduction to chemistry, you find the videos. So all these topics have been taught. Alright. right? So it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A Plus Academy app and start learning and practicing with our solved materials. Right, so welcome back to the video, and then we're going to solve question 2. Let's start with question 2. Then when I'm done with question 2, I'll go to question 3. So question 2, we have these functions. They want us to determine the domains of the following functions. So let's proceed. Okay, so the question is like this. They want you to find the domain for x plus square root 3x minus 4. So if you are somebody who has watched my video lessons on A Plus Academy app, you already know that I've explained that whenever they tell you to find a domain for two functions that are adding up, you have to find individually the domain for this and the domain for this. Then you find the intersection at the end. So you have to find the intersection at the end by using the concept of interval notations. I'm going to show you what I mean. So let's begin by finding the domain for x. So now x is a linear function, and trust me guys, there's a video on A Plus Academy app where I taught interval notations. Where I taught domain and range, like from basic to advanced, and I explained every detail about the types of functions and how to find its domain. So this is a linear function, and the domain will always be the value of x can be anything, any real number, right? So the value of x can be any real number. We can present this also by writing that the value of x can be any number in the x-axis from the negative infinity to the positive infinity. Okay. So listen, I'll be expressing my answers in interval notations. Why? Because I need to use set intervals at the end. Okay, so I'll leave my answer in this format. Even this is correct, but for learning purposes and for me to easily plot it, I'll leave it like this. And then let's find the domain for 3x minus 4. So the domain for this, remember, whenever you're finding the domain for anything involving square root, anything involving or let me say anything that is involving roots which are even, like square roots, the fourth roots, whatever is under the square root can never be less than 0. So you're going to write whatever is under the root, which is 3x minus 4, and say it is greater than or equal to 0. Okay, and then we solve for x, so we say 3x is equal to 3 greater than or equal to, I'll take 4 on the other side, which will be positive 4, right, over 3 over 3. And then it's going to be x greater than or equal to 4 over 3. Makes sense, right? Now I can write this in interval notations by saying the value of x. So listen, it is greater than here, so meaning that we're starting from 4 over 3 going to the positive infinity. And if you don't understand how I'm doing this, go and watch the video lessons of interval notations. The video lessons are already here on the YouTube channel. There's part 1 and part 2 video of interval notations on this YouTube channel. So make sure that you watch those 2 videos. If you don't understand after watching them, then trust me, there's something wrong with you, because every student who has watched those videos, they have understood interval notations. So we can also write this as 4 over 3 to positive infinity. Okay, so now I am going to now I have 2 domains. Okay, so I'm going to draw a number line. So on this number line, I'm going to plot this and this. I'm going to plot these 2 domains. So the first domain is the domain for x. I'll plot it, which is showing that from negative infinity to positive infinity. So I'll say negative infinity to positive, my god, positive infinity, and then the domain for this one, which is this. So let me just put 4/3 here, and then we're starting from 4/3, right? And it's part of the set, so I'll shade the bubble. Then we're going to the positive infinity. Okay, so the intersection is where we can, the region where we can find the values found in both this domain and this domain, and it is this region right here. So we are going to describe this region as starting from 4/3, which will be part of the set, going to the positive infinity. Okay, I'm sure by now you understand. So I'll quickly solve this one. So even this one, you find the domain for this and this separately, then at the end we intersect. So let's find the domain for square root of x. So I'll get what is under the square root. I'll say it's greater than or equal to 0. Then come for domain for square root of x minus 1. I'll get whatever is under the root. I'll say it is greater than or equal to 0. So for x, which is 1, right? And then now, so look, I have these two. I need to write them in intervals. So here we're starting from 0, going to the, since it is greater than here, we're starting from 0, going to the positive infinity. So it's going to be, since there's equality sign here, I'll use this square, the square bracket, and I'll put 0 to the positive infinity. Okay, and then for this one, I'll start at 1, going to the positive infinity. So we quickly put them on the number line. Quickly put them on the number line. And then so I'll say 0, 1. Okay, so let me plot this one here. So I'll shade the bubble. Then I'll go to the positive infinity, like this. Then here, where there's 1, I'll shade the bubble and go to positive infinity. Okay, so now the region where we can find the intersection of this and this is this region here, and we can describe it as starting from 1, which is going to be part of the set because the bubble is shaded. This is a concept under interval notations. Okay, go and watch the video if you haven't. Then going to the positive infinity. So this what you're seeing right here is the final. It is the final domain. So this is the domain for this whole function. Have you seen? So always remember that if the two given functions are adding, subtracting, multiplying, or dividing, you need to find the individual domains, then intersect them. Okay, so let's go to 3. Alright, so let's come to this. So look, this question is tricky. Why? Because we are having a fifth root, not a square root. Now let's talk about roots. You know, we have this one, which sometimes we can even put a 2. So this one we call it a square root. We can, behind the scenes, it has like a 2 here. This one is a cube root if there is 3. Okay. And if here there is a 4, you can just call it the fourth root. If there is a 5, like this, it is a fifth root. Now, if the type of root, look, this is the second, there's number 2 here, right? Here there's number 3, here there's number 4, here there's number 5. So, if the root is divisible by 2, like this one, their roots are divisible by 2, right? We can call them even roots, okay? And these ones, this and this, we can call them odd roots, 3, whereby the cube root and the fifth root and so on, they are not divisible by 2 without, okay, look, I mean, they are divisible by 2 without leaving any remainder. That's my point. So this and this, they are even roots because they are divisible by 2 without leaving any remainder. But these, we can call them odd roots because, of course, they can be divisible by 2, but they will leave a remainder. So if we are having an even root, when you are finding the domain should always be greater than or equal to 0. It should not be less than 0. It should always be greater than or equal to 0, like what we've been doing. Okay. Now, if there is 3 here or 5 here, if they are odd roots, their domain will always be from negative infinity to positive infinity. There are no restrictions. Okay. I want you to get the difference. So here your final answer is this, because we just have one function and you're done. Because this is an odd root, because there is 5. Even if there was 3, we can just change it. Or if you want, you can even say the value of x is any real number. Okay, let's go to question 4. Question 4, we have kx is equal to, this is the fourth root, to x plus 3. Now, fourth root. This root is an even root, right? It is divisible by 2 without leaving any remainder. So meaning that we can proceed and say whatever is under here cannot be less than 0. So we can explicitly say that 2x plus 3 is greater than or equal to 0. Say 2x, we take 3 on the other side, we say over 2, x greater than or equal to negative 3 over 2. So how do you write this in intervals? When you are concluding the domain, try to be expressing your answers in intervals. Like, it's just a good practice. Okay? If your lecture is even strict, your lecture is strict enough, this is 2x, because I wrote the wrong stuffs. Yeah, so you can also write this as from negative 3 to positive infinity. Okay, so let's solve question. Wait, have I skipped a question or what? Okay, so let's solve question 5. So question 5, you're going to find the domain for this individually. So let's start. Domain for this. So this one, you know that this is a quadratic function. So a quadratic function, the domain is always any real number, or from negative infinity to positive infinity. If you've watched the videos on quadratic functions, you must understand that. I taught that. So always know that quadratic functions, their domain is always from negative infinity to positive infinity, meaning that it can be any value of x in the number line. I mean in the x-axis, from negative infinity to positive infinity. And then we find the domain for x power 2 plus 4x minus 12. Right. So this is a quadratic. No, I mean it's a square root. So we get what is under the square root and say greater than or equal to 0. Okay. And then after you do this, okay, so you're going to solve the quadratic. Factorize this quadratic function. So the product is negative 12. The sum is 4. So what could be the possible factors? The factors, we can have 6 and negative 2. When we multiply, we get negative 12. When we sum them up, we get 4. So we are going to have, so look, we are going to solve this quadratic, and it should give you 2 values of x. Then you plot on the, then you plot on the number line. So for now, we are just on this one. Okay, so we have x power 2 minus 2x plus 6x minus 12. factor out x, we remain with x minus 2 plus 6 x minus 2. So we have x plus 6 x minus 2. Okay, so I will just get this and this, then equate them to 0. So to find the critical point, so we are going to use the sign table to find the proper region. Okay, so if I equate this one to 0, I'll get negative 6, right? And if I so if I get this then equate to 0, I'll get positive 2, right? So you draw the sign table. I'm just using my free hands right now, so the table might not be perfect. So I'll write x plus 6, x minus 2. So here I'll put negative 6, here I'll put 2. So I'll say if I put 6, let's assume the value that can be here, let's say negative 7. Here let's put 0, here let's put 5. So if I put negative 7 here, I'll get a negative. If I put negative 7 here, I'll get a negative. So here I have positive. If I get 0, I put it there, I'll have a positive. I have negative, so here is negative. If I put 5 here, I'll get a positive and positive. Now, since here is greater than or equal to, I'm going to focus on the positive regions, which is this region and this region. So the first region is from negative 6 to negative infinity, or from negative infinity to negative 6. Wait, so listen, I'm going to use this one, square bracket, because there is an equal sign here. So this is a square bracket saying that even negative 6 is part of the set. Then the other region is this positive region, which is from 2 to positive infinity. Okay, so now I've just found the domain for this function. This is the domain. So now I'm going to put them on the number line. Let me do this. Okay, so I'm going to put the domain for these two functions. So let's start with this. So okay, let me do this. So I'm expecting to first, let me put 0 here, then negative 6, and then 2. So the first one is from for the first function, the domain is from negative infinity to positive infinity, right? Then the other one is this one here. So this domain is having like two parts. So there is one from negative 6, which is going to be shaded, to negative infinity, and there is another one from 2 to positive infinity. Okay, now we need that region. I'm doing this to just show you. Okay, I know the final answer. I don't even need to draw this number line. I can just look at the domains. I can even tell the final answer. So the region is this one. That's what the intersection is, which we can describe as, from here to here, which is negative infinity, comma, negative 6, union, then from here to the infinity. So now look, whenever you have two functions whereby the first function is giving you this type of a domain, negative infinity to positive infinity. In the second one is giving you a different one, like this one, or a different one, which is not in this manner of negative infinity to positive infinity. When you put them on the number line, you try to find the intersection, you're going to get back the domain for the other function, which is not in this format. But it's good that you just apply some concepts for interval notations for practice purposes. So this is the final answer. Alright, so for this one, we're going to get what is under the square root, which is x plus 1 over x minus 1 greater than or equal to 0. Okay, and then how do you solve this type of equation? So we're going to find the critical points, then we draw the sign table. So the critical points, just equate this and this to 0. So the numerator is equal to x plus 1 is equal to 0. It's going to be x is equal to negative 1. But for denominator, it should not be equal to 0. So we equate to a non-zero. So it's going to be x minus 1 is not equal to 0. So x cannot be equal to negative 1. So we have the critical point here, and let's draw the sign table. Guys, I'm using my free hand, so the lines might not be perfect, but I hope you are getting the concept. Alright, so wait, this will be positive, yeah. Okay, so here I'll put negative 1, here I'll put positive 1, and here I'll put x plus 1, here I'll put x minus 1. So here I'll put negative 5, here I'll put 0, here I'll put 2. Okay, so if I put 5 here, I'll get a negative value. If I put 5 here, I'll still get a negative value. So here I'll get a positive. If I put 0 here, I'll get positive, negative. So negative here. If I put 2, I'll get positive. So listen, since we have a greater than symbol here, we're looking for positive region, and we're going to do this. So the positive region is this. So we start from negative infinity to negative 1. So I'll say negative infinity to negative 1. Should be negative 1, not positive 1. And it should be square bracket because this is going to be part of the set. Then we say union. Then the other region is this region, which will be from positive. Now listen, since we said that it cannot be equal to positive 1, so I won't use the square bracket, I'll use the parenthesis, then I'll put 1 to positive infinity. So this is my domain. So I hope you've understood question 2. Let's go to question 3. Alright, so this is the A+ Academy app where you can find more of our videos. So you're on term 1, pH 110. So under physics, you are going to find more videos under these topics. Vectors, there are all these videos which will get to learn at your own pace. In these videos, we've taught everything. Okay, it's not just physics, even these other courses like chemistry, mathematics, and biology. Okay, so make sure that you contact me to have access to our simplified video lessons on the A+ Academy app and get to learn at your own pace. These videos are pre-recorded, so you no need for you to attend any online lessons. You just watch from anywhere whenever you want and learn at your own pace. Okay, so let's go to question 3. So question 3 is saying that the function, this function, is such that f of negative 1 is equal to 3 over 2, and f of 2 is equal to 9. I'll explain. Find the values of a and b, and then find the domain of function f. Determine whether f of x is 1 to 1. So listen, they have given you this function. So the first condition given is this one, where they have said look, the function given is what? Is f of x, right? Is equal to what is here. So if they say that f of -1 is equal to this, they are simply telling you that your first condition is that where there is x, you have to put -1. And then when you put -1 where there is x, what you are going to have equated to 3/2. So that is going to be our first equation. And then the other condition given is that f of 2, meaning that when you get this function again, where there is x, put 2. So we're going to put 2 where there is x. And what we're going to have, we equate it to 9. That will help us to formulate second equation. And then we are going to end up with two equations. These two equations, we are going to solve them simultaneously to find the value of a and b. I've just explained verbally what I'm going to do. Now I'll show you mathematically how we're going to do it to find a and b. Then after we do that, after we find a and b, we are going to find the domain for the function. Because listen, we are going to end up with the values of a and b, meaning that you're now going to have a full-fledged function. Then that function, you're going to find its domain. Then we also determine whether it will be 1-to-1. So now let me show you what I mean. Alright, so here's what I mean. So they have given you this function, right? It's equal to a over x plus b. So the first condition is that, they have given you two conditions. The first condition is that f of -1 should be equal to 3/2 based on this function. Let me even circle it. So with this condition, we are going to find the first equation. And how are we going to do it? So let's get this function. Where there's x, I'll put -1. So I'll say a over, where there's x, I'm putting -1 plus b. Then I'm equating to 3/2. 3/2. Okay? And now I need to try to simplify this equation. So first of all, let me get rid of this. So I can also write this as -a plus b is equal to 3/2, right? Then I can multiply throughout by 2 to get rid of this denominator here, so that I can just remain with that, a simplified version of an equation. So I'll say 2 times a is going to be -2a plus 2 times b is going to be 2b. It's equal to 2 times this one. These 2 and 2 will cancel, because it's going to be like this, 3/2 times 2. These will cancel, and I'll just remain with 3. So I'll record this as my first equation. Okay, so now let me find my second equation. Second equation, we are going to find it based on the second condition which they gave. The second condition was that, so I want to take note of this. When you start solving them simultaneously, this will be our first equation. So let's find the second equation based on the condition which they give us, that f of 2 is equal to 9. F of 2 is equal to 9. Okay, so I'll get this initial function here. I'll say a over, so since it is f of 2, where this x, I'm going to put what is here, which is 2. So I'll put 2 plus b is equal to 9. Multiply through by 2. So it's going to be a plus 2b is equal to 18. This will be our second equation. Okay. So now we have two equations. I have this equation and this equation. Let me write them properly. So we have -2a plus 2b is equal to 3. And if you want to access all the solved materials, all the solved tutorials, make sure that you subscribe to A+ Academy app. I'll share the contacts. You can contact me to have access to the app. So you have a plus 2b is equal to 18 as our second equation. So we can solve them simultaneously. But how? So me, I'm a fan of substitution method. If you've been watching my lessons, you will know that actually I'm not comfortable with the other methods when it comes to simultaneous equations. So if you want to use the elimination method, I'll use substitution. So I'll make A my subject. From the second equation, it should be 18 minus 2b. You know, substitution method is a method that you use like everywhere. There are some calculations which you can only use substitution method to solve simultaneously. So if you make this your favorite, you'll find that physics will be enjoying. Anything that is involving substituting you'll be enjoying, and it is always there in physics, chemistry, and math. So where this A, I'll put this, so it's going to be negative 2, 18 minus 2b plus 2b is equal to 3. Then, okay, so 18 times 2, so it's going to be 36 plus 4b plus 2b is equal to 3. So negative 36, 4b plus 2b, that will be 6b is equal to 3. So I'll take 36 from the other side. I'll have 6b is equal to 3 plus 36. So 6b is going to be equal to 36 plus 3 is going to give us 39 over 6. So b is going to be equal to 39 over 6, which we can simplify as 6 into 39, it is 13. No, 3 into 39, it is 13. Then 3 into 6, it is 2. So I can simplify this as 13 over 2 as the value for b. So now that we know the value for b, let's find the value for a. So the value for a, I'll use this equation here. I'll just put 13 over 2 where there is b. So I'm out of space. So it's going to be a is equal to 18 minus 2. Where there is b, I'm putting 13 over 2. I know it's not clear. Let me write that again. A is equal to 18 minus 2, 13 over 2. So 2 and 2 will cancel, right? And I'll have A is equal to 18 minus 13. Right? And A is going to be 5. So the values are these. So A is equal to 5 and B is 13 over 2. So we have found the values. And if you are doubting, you can prove this equation. This is provable. The answers are correct. Okay, so remember that the function that was given was like this. A over x, A over x plus b. And then we have managed to find the value for a which is 5, and 5, b which is 13 over 2. So we can find now the original function, like without a and b, in terms of its numbers by substituting. So where there's a, I'm putting 5 over x, and then plus, where there's b, I'm putting 13 over 2. This is the function now. Now question 2, they are saying this. They are saying that find the domain of function f. So you're going to get this and find its domain. So I'll say, let me write it again. So let me make it a single fraction. Make it a single fraction. This into this, it is like 2, right? 2 times 5, that is 10. This into this, it is x. X times this, that is 13x. Alright? So the answer is 10 plus 13x over 2x. So basically, I'm telling you to find the domain for this. And for you people who have been following our video lessons on A+ Academy app, you know exactly what to do here. So here's what you do. You're going to get the denominator you know that this cannot be equal to 0, because if the denominator is 0, then we have an undefined, right? So I'll say 2x cannot be equal to 0 over 2 over 2. So x is equal to x cannot be equal to 0. So the domain is that, look, so here's how you describe your here's how you describe your domain. Your domain, or your domain is this: your value of x can be anything, literally anything that's a real number, but that value of x should not be equal to 0. So we can describe in this format. We can say the value of x can be any real number. On one condition, it should not be equal to 0. You even close. Or if you want, you can describe like this, like, okay, it can be any value from negative infinity, but 0 should not be part of it. And then from 0, we can continue, we should skip 0 and continue going to the positive infinity. No, not this. There should be a parenthesis, yeah. So we can also describe it in intervals. So any that will make sense, your lecturer will still mark you. So this and this, they are the same. So let's go. So the third question, they are saying that determine whether the function of x is 1 to 1. So we have 10. After simplifying the function, if you remember, we had 10, 13x over 2x. So they want you to show that this one, if it is 1 to 1, and if a function is 1 to 1, this is function of x. If the function is 1 to 1, f of a of that function should be equal to f of b. When you simplify them, they should give you a. Not they should be equal to f of b. F of a, when you simplify it, should give you a, and f of b, when you simplify it, it should give you b. Here's what I mean. So let's get the function of the original function. While is x, I'll put a. This is f of a. I'm trying to show you. While is x, I'm putting a. So this, on the left side, it is f of a. While there's x, you put a. Then f of b can be written like this: 13b over 2b. Okay. Now we can cross multiply. 2 times, we cross multiply them. So it's going to be 20b, and 13 times 2, that is 26ab, and 2a is going to be 20a. This is 2a basically. Then 2a times 13 is going to be 26ab, right? So we can try to simplify this. So I'll take what is on the right hand side to the left side. We see what can be subtracted from which and which. 26ab minus 20a minus 26ab. Because when you take what is here, the sign will change. So if you see 26ab and 26ab, they are like terms, and they are having different signs. Okay, so we can simply cancel these and remain with 20b minus 20a. So I'll take this on the other side. I'll take the 20b on the other side. Here I'll remain with negative 20a is equal to 20b. I'll take it there. Like I just want to remain with I just want to remain with a on this side and b on the other side. So I would have negative 20b. Divide through by negative 20 over negative 20, and we remain with a is equal to b. So for the fact that after simplifying this expression, we are able to end with this, it means that this is indeed 1 to 1. So we can even write that and conclude. Alright, so let's go to question 2b. So they have given you this function, and they're saying that g of x is equal to 1 over x. Let this function and this function be two given functions. So the first one, they want you to find f of 1 over 4. So meaning that they're just telling you that get this function, which is having f, while there's x, put 1 over 4 and simplify. That's it. Then question 2, they're saying find the domain and range of the function f. Just find the domain and range. Then this one, they're saying show that a function f is 1 to 1. And it's very simple, right? So let's solve it quickly. Alright, so we have f of 1 over 4. So we say f of x is equal to x plus 1 and 2x minus 1. Right? So to find f of 1 over 4, just substitute why this x, put 1 over 4. So it's going to be 1 over 4 plus 1 over 2, 1 over 4 minus 1. Right? And then, so this is 1 over 4, guys. Forgive my handwriting. You know, some of us were not blessed. Look, some of us were blessed academically in these other aspects, even the looks. Some of us, in case you guys have never seen me in real life, I'm blessed. Now, when it comes to the handwritings, trust me, guys, we are not that much blessed. So just focus on the knowledge I'm sharing with you. So 1 over 4. Alright, so here is the thing. You need to simplify the numerator and the denominator and remain with a single fraction. You need to simplify this. Don't just substitute and hand a. No, show some efforts at least. Okay? So, you know, I can also write this as 1 over 4 plus 1 divide by 2, 1 over 4 minus 1. Okay, and then now let me just write it here. I can have enough space. So I can simplify this, right? 2 in this, so it's basically 1 over 2 minus 1. So denominator 4, 1 here, 4 times 1, that is 4, and then 2, 1, 2, right? So I have 5 over 4. Let's hope I'm not mistaken. Divide by negative 1 over 2. So since we are dividing, we can also write this as 5 over 4 times negative 2 over 1. So which is going to be 5 times negative 2, it is negative 10, right, over 4. We can simplify this further by dividing 2 into this and this. So 2 into 10, it is 5, right? 2 into 4, that is 2. Just like this. Okay, so let's go to question 2. So question 2, they are saying that find the domain and range for the function x plus 1 over 2x minus 1. Alright, so this is the A Plus Academy app where you can find more of our videos. So you're on Term 1, PH110. So Under physics, you are going to find more videos under these topics. Vectors, there are all these videos which will get to learn at your own pace. In these videos, we've taught everything. Okay, it's not just physics, even these other courses like chemistry, mathematics, and biology. Okay, so make sure that you contact me to have access to our simplified video lessons on the A Plus Academy app and get to learn at your own pace. These videos are pre-recorded, so you no need for you to attend any online lessons. You just watch from anywhere whenever you want. Alright, so let's find the domain for the function f, which is x plus 1 over 2x minus 1. So to find the domain, you need to assume that what is on the denominator, or we need to say that what is on the denominator should not be equal to 0. Should not be equal to 0. Then I'll take this negative 2 on the other side. Because if what we have in A is equal to 0, we are going to have undefined, and we don't really want to have that. So we'll divide by 2, divide by 2. So x should not be equal to 1 over 2. So to state your domain, you can say x can be any real number, but it should not be equal to 1 over 2. Because look, if I put, my bad, I need to put the bracket. Yeah, so if I put 1 over 2 here on the denominator where this x, I'm going to have 1 over 2, right? This is going to give me 1 minus 1, and it will be 0. Have you seen? So it should not be equal to 1 over 2, because if I have x as my 1 over 2, I'll get 0 when I substitute. And we don't have to have 0 on the denominator, because if you have 0 on the denominator, it means that that function is now undefined. Makes sense, right? Now, they want us to find the domain. We found the domain. Now let's also find the range. Okay, so how do we find the range? So to find the range, let me do this. Say range. So to find the range, I'm going to find the inverse of this. Like I'll use the procedure of finding the inverse. So here's what I'm going to do. So to find the inverse, I'm going to say y is equal to x plus 1 over 2x minus 1. Then I'll cross multiply. So I'm going to have y 2x minus 1 is equal to x plus 1. Right? Expand this here. So we have 2xy minus y is equal to x plus 1. So let's make, we need to make x the subject of the formula. Always remember that. So I need to have the values that are having x on a certain side alone, then those that aren't having x on the other side. So I'll have 2xy, this x is going to come here, it will be negative x. 1, this is, when this y goes there, it will be plus y, right? So I'll factor out x, so I'll have x outside there, and I'll have 2y minus 1 is equal to 1 plus y. Makes sense? And then I need to have x as my subject to the formula, right? So I'll divide through by 2y minus 1. These will cancel out. Then I'll remain with x is equal to 1 plus y over 2y minus 1. And then finally, now we can proceed and find the range. So to find the range now, we're just going to get this denominator here. Okay, so let me just try to rewrite it. You know, I know some of you might be like, what are you writing? Okay, so I'll need to get this denominator now that I have, and say it should not be equal to 0. And what I'll find is my range. Remember, domain, it is the value of x, like the value in the x-axis. Okay, if you hear the word domain, think of the values in the x-axis. That's why we are interested in the x. Now, if they speak about range, we are looking for the y value, and the only way in which we can get the y value is by using this procedure till we end up with these y values on the denominator. Listen, look, I know I said we need to find the inverse, but we are literally not finding like the final answer is inverse. We need to end here. Look, we use the procedure of finding the inverse, but we don't really conclude with the inverse, like, no, the inverse of x will be no. We just end on this step where we have y on the denominator, okay? Because range presents the possible values of y which this function can accept without giving you undefined. That's the range. And then domain, it presents the possible values of y that this function can have without ending up with undefined, which we have found. So now for the range, we're talking about the y-axis, okay? Whenever you hear the word range, I repeat, think of the y, anything in the y-axis. So I'll get the denominator 2y minus 1. And I don't want it to be equal to 0, okay? Because if it is equal to 0, we'll end up with an undefined function. So make y your subject. Alright. Let's hope we haven't made any mistakes, guys. If I have, try to understand. Right, so we know that y should also not be equal to 1 over 2. So we can also conclude that even y can be any real number, okay? But I don't want this y to be equal to 1 over 2. So this is how you solve this kind of equation. And if you want to access more of our simplified video lessons, tutorial video lessons, which we've pre-recorded, we've taught all the NS syllabus, not just in math, we've simplified chemistry, physics, and biology as well. Make sure that you download the A+ Academy app. Alright, so let's proceed to the next question. Okay, I hope you understand. Let's go to question 3. So they want you to show that this function f, is 1 to 1. So remember, if a function is indeed 1 to 1, when you find f of a, you simplify it, and you find when you equate f of a and f of b, then you simplify them, you should end up with a equal to b using this function. So let me find f of a. So where this x, I'll put a plus 1 over 2. Where this x, I'll put a minus 1 equal to f of b. Where this x, I'll put b plus 1 over 2. Where this x, I'll put b there, and then minus 1. Then what do? So I'm going to cross multiply these. So we're going to cross multiply them. So I'll say a plus 1 times 2b minus 1 is equal to b plus 1 multiplied by 2a minus 1. Then we cross multiply them. So this time this it will be 2ab. This time that is going to be negative a. This time this is going to be plus 2b. This time this it will be negative 1. Then this time this it will be 2ab. This time this it will be negative b. This time this it will be 2a. Then 1 times this is going to be negative 1. Let's simplify. If there is anywhere where we can simplify, nowhere, right? So what I would do is this. I would take this. Oh, look, you don't have to stress about taking what is here on the other side. Let me give you a trick that I use, okay? Just check, are there any stuffs that are on this side and this side which are the same, whereby they are like terms and they are having same signs? Let's spot. So like I've spotted this one here. Here I have negative 1 and here I have negative 1. They are on the opposite sides. This on the left side, this on the other side. And they are both like terms and they are having same signs. So if they are like this, the signs both are negatives. They are on opposite sides. So they can be cancelled out. Okay. What else? And I think I have two. Another thing. I have 2ab and I have 2ab. These two are having same signs and they are of like terms, so we can also cancel them out. And what have I just remained with? I've remained with negative a. If you want, take what is here on this side, simplify, okay? If we are not clear with this trick. So here I have 2b and here I've remained with negative b plus 2a. So I'll take now these things on the other side so that you guys can just see. But me, I can solve this in my head, okay, without having to do all this. So I'll say plus b minus 2a is equal to 0. So this plus this, it is 3b, right? This and this is negative 3a. So I can take this on the, I need to end up with a on this side and b on the other side, right? So I'll leave this on this side, then 3b, I'll take it on the other side. Then actually it will be negative. Then I'll divide through by negative 3. So they will cancel, right? Then I'll remain with a on this side and b on this side. So since I've managed to remain with this, it means indeed they are one-to-one functions. It is one-to-one function, and we have shown. So let's find question 4. Right, so we have f of x is equal to x plus 1 over 2x minus 1. Then we also have g of x, which is equal to 1 over x. Now, they have asked us to find also the composition of f of g of x. Basically, they're saying that get this function here, and where is x, put the other function. Get me clearly here. Let me write it. This function, have you seen? Wherever there is x in this function, which they have started with, substitute the whole function of g, which is this thing here. So I'm going to have, if I substitute where there's x with 1 over x, I'm going to get 1 over x plus 1 over 2, 1 over x minus 1. Make sense? And then we are going to simplify them now. So these I can also write them as 1 over x plus 1 divide by 2 over x minus 1 over x. So this into this it is 1. 1 times 1, that is 1. This into this it is x, right? Then this into this it is 1 x right. I hope we are moving together. Are we moving together, or I'm moving alone? Alright, so we're going to have divide by, right? So we can also write this as 1 plus x over x times x over 2 minus x, which is going to simply give us x plus x power 2 over 2x minus x power 2. So this is, if we've done the calculations properly, I hope I haven't made any miscalculations here. Yeah, so, and if you want, you can even factorize this. You can at least leave it like this. You can just leave it like this. I think it makes much more sense. But either ways, so look, your job is to just do this. Where is x in f? Substitute the whole function of g and simplify. This is composite functions. We have a composite function here. Alright, so let's find the domain and range of this function. So domain is a bigger story. You get what's on the denominator, right? Get what's on the denominator and say that it can never be equal to 0. So we're going to say, oh, actually, let me show you the question that we are solving now. So we are solving this question. Let f of x be equal to x minus 3 over x plus 2 be a function. Then question 1 is saying, I thought that I've already showed you this. Question 1 is saying that find the domain and range of f of x. Question 2 is saying that find also the inverse f of, which is presented by this, of the same function. Basically, they're just in find this, find the inverse of this function. Then question 3, they are saying given also that g of x is equal to this one, solve the equation such that this is equal to 1. I'll explain what they mean here. Just take note. If you are following along, pause the video and write down. But I hope that you have the tutorial sheet. Let's hope you screenshot it when I just showed you at the beginning of the video, because I won't really be going back to the questions unnecessarily. Alright, so the first one, they just want us to find the domain. So to find the domain, so we say x plus 2 should not be equal to 0. Then solve for x negative 2. Okay, so listen, you can say this, that okay, the x can be anything which is a real number, but it cannot be equal to negative 2. And just like this, you are done. And then the second question, they're saying, oops, we haven't found the range. Oh yeah, so we found the domain. So now, to find the range, you need to use the procedure of finding the inverse. How do you go about it? So I'll say y is equal to the whole function x minus 3 over x plus 2. Cross multiply them. When you cross multiply them, yeah, so cross multiply them, we have x plus 2 is equal to x minus 3. So expand, yx plus 2y is equal to x minus 3. So I need to make x my subject. So I'll take x on the other side, yx minus x is equal to negative 3, negative 2y. And then I'll factor out x, then I'll have y minus 1 is equal to negative 3, 2y over y minus 1 over y minus 1. And x is going to be equal to negative 3, negative 2y over y minus 1. Okay, so listen. This procedure is the procedure that we use when you're finding the inverse. And it's the same one that we use when you're finding the range. It's just that we end here. And when we where we have y on the denominator simplified like this, we now say y minus 1 cannot be equal to 0. Y should not be equal to 1. So meaning that you can say that the range can be all possible values of y, which are real numbers, but y should not be equal to 1. Like this. Okay, so we have simply found, so we have found the range just like this. Now these are question 2. Question 2, they are saying find the inverse. So look, to find the inverse, you do the exact same thing that I did here. You equate to y, you simplify. So me, I'm just going to continue from here, okay, because assume that I've already started. Okay, so to find the inverse, I'll say x is equal to, but you, since you know most of the lectures are strict, just start over. Just write exactly what I've written here, the same procedure. Then say 2y over. Now for the inverse, you don't end here, you exceed, you go beyond. So you're going to say f inverse of x. So where is y, you put x minus 1. Okay, so by just doing this, you have found the inverse. So have you seen the difference? When you're finding the inverse, you go beyond, you just do this. But when you're finding the range, just end here, equate the denominator to not into a non-zero, then solve for y. Right? So question 3, they are saying that also given g of x, let me show you. Yeah, so question 3, they are saying that given the function g of x is equal to 1 over x plus 1, solve the equation f of g of x is equal to 1. Remember that f of g was given to be, the function of f of x was given to be x minus 3 over x plus 2. This is 1, guys. Yeah. So you need to get the function of f. Here it's more like they're telling you to find f of g. Then the f of g equated to 1. Meaning that get the function of f. Where there's x, put the whole function of g. So I'll get this. Where there's x here, I'm going to put 1 over plus 1 minus 3 over 1 over x plus 1 plus 2, then equate to 1. So your job is to simplify the numerator in the denominator, and then you solve for x. As simple as this. So you know that so here's how you can simplify this. So you can do this. You can say 1 over x plus 1, simplifying like a grade 1, divide by 1 over x plus 1 plus f. This is where you access all the full videos. So what you just do is come here on videos and then click on term 1, term 2 or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions, if you haven't understood everything that we've learned so far, or that we're going to cover in the video. Okay, so all these topics, okay, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are. Then you catch up at the end of the day. And we have a lot of students who are watching these videos and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. You're going to find videos about it. Okay, but it's not only math, even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just use CH110. You find the videos here. Okay, if it's introduction to chemistry, you'll find the videos. So all these topics have been taught. Alright, so it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A Plus Academy app and start learning and practicing with our solved materials. Alright, so let's go to the third question. So the third question, they want you to find let me read it. Given also that g of x, which is this one. Now they have also given you g of x. Solve the equation. They want you to solve this equation of, this is f. Okay, let me see. Yeah, of so they're saying solve the equation f g of x. It should be equal to 1. So they're simply saying that find f of g, then equate it to 1. Now, how do you find f of g? F of g is when you get this function of f. Then where there's x, you substitute the whole function of g. Meaning where there's x here, I'll put this whole thing. Where there's x here, I'll put this whole thing. I have found f of g. You substitute into the function that is coming here, which is f, this function. So where there's x, I'll put 1 over x plus 1 minus 3 over 1 x plus 1 what am I doing? Plus 2 is equal to 1. So look, your job is to simplify this whole expression. After you simplify, then solve for x. So this expression, for you to simplify it easily, you can break it down. Look, these steps I'm showing you are what you should be doing on your exam. Because this question, I think you can't avoid it. They like bringing these types of questions. So you can write this function as this. This expression, you can also write it as 1 over x plus 1 minus 3 divide by 1 over x plus 1 plus 2 equal to 1. Listen, what I'm having here and this one are the same. It's just that it is easy to simplify if I do it like this. So now I can simplify each. Common denominator is x plus 1. This into this, it is 1, right? It is negative 3x plus 1. We come here, x plus 1. It's going to be 1, right? It's going to be plus 2x plus 1 equal to 1. So here it's going to be 1 minus 3x minus 3. Yeah. Then x plus 1. Look, I can do this if I want. I'm using these brackets to just separate them, to make them look organized, so that you don't get confused. Okay? Then here it's going to be 1 plus 2x plus 2 over x plus 1. Then equates to 1. So let me simplify this side. I have negative 3x minus 3 over x plus 1 divided by 2x plus 3 over x plus 1 equal to 1. Okay, so I can also write this as negative 3x minus 3 over x plus 1 times, look, I can also write this as x plus 1. If I put times here, if I change this from divide by to times, these are going to swap. I hope you remember this grade 1 concept. Some don't even know this. Okay, now look, this and this can cancel each other, right? Don't forget, equal to 1. And when they do that, you're going to remain with negative 3x minus 3 over 2x plus 3 equal to 1. Okay. Wait. There's something that we've forgotten here. This one. After expanding, there was a plus 1. Do you remember it? We should have... let me show you. We've forgotten to do something here. So what I wrote here was just an expansion. I forgot this one. So basically we have 1 plus negative 3. It's like I have plus 1. So it's like I have plus 1 here. I hope you remember. Try to simplify this. You see that I forgot to write the plus 1 after expanding. That's why when you solve, it's very important that you pause and go through. Have I done the right things? So when I include that one which I forgot to write, I'm going to have negative 3 minus 2 over 2x plus 3 is equal to 1. So have you seen how we've simplified from this complicated thing here to our simplified version, which we can easily solve for x? Have you seen? So make sure that you take your time and break it down like this, and don't make this mistake. I almost made. And these mistakes are very normal, especially if you are rushing. You find that you forget to write maybe a negative, you forget to write a sign, you forget to change the sign. So always when you solve, pause maybe like for a minute or a few seconds, go through. Okay, is everything okay? Then you proceed. Alright, so we're going to cross multiply. Negative 3x minus 2 equal to 2x plus 3. Negative 3x minus 2x is equal to 3 plus 2. 3 plus 2. Negative 5x is equal to 5 over 5 over 5. X is equal to, and it is negative here, don't forget. So x is negative 1. Let's go to D. So D, I want you to show that the function f defined by f of x is equal to, where x is all the possible values of x are real numbers, is subjective on real numbers. So how do you show that the function is bijective? So if a function is bijective, it needs to be both injective and surjective. If it is injective, it means it is one-to-one, and if it is surjective, it means that there's an inverse, right? So your first step is to see if this one has got an inverse. If it is one-to-one. If it's not, means it's not injective. So meaning that it's not even bijective, because it has to be both. If you don't understand this, then just go and watch the video lesson on A+ Academy app, where I taught how to show if a function is bijection or not. Okay. Alright, so if a function is one-to-one, it means that f of a, when we equate f of a and f of b, then simplify them, we should end up with this. So I'll say a over square root a power 2, this is a plus 2, this power 2 here, equal to b, here I'll put b power 2 plus 1, cross multiply, b power 2 plus 1, b a power 2 plus 1. Okay, so let me raise both sides to the power of 2 to get rid of the square roots. So I have a power 2 and b power 2 plus 1. Your job is to just simplify, and there are people who have just mastered. So if they see this type, which is having square roots, they will think it's something else. Just get the concept in math if you want to be good at math. A power 2 plus 1. When you raise both sides to the power of 2, the square roots, they will cancel, will go out. Okay. Then we multiply through. We have a power 2, b power 2 plus a power 2 is equal to b power 2, a power 2 plus b power 2. Now this and this will cancel because they are on both sides, and we have a power 2, b power 2. So now look, our goal is that when we simplify, we should end up with this. Is there a way in which we can simplify this such that we just end up with a and b? Let's try to introduce square roots. When we square root both sides, of course they are going to cancel, plus or minus, but we are going to have plus or minus a and plus or minus b. But this is not what we are looking for as our final answer. We are looking for just a equal to b as our final answer. So this is not a bijection, because it is not one-to-one. Look, unless in a case whereby you didn't have square roots but you had cube roots, because when you introduce cube roots, you don't introduce positive or minus. Plus or minus. Plus or minus is only introduced when you're introducing square roots. So if we were introducing cube roots, we wouldn't have had this scenario. It would have been one-to-one. Alright, so let's solve question 4. So question 4 is they're saying that determine whether the function f is even, odd, or neither. So there's a drop of water here. So this is the function of x. Okay, so this question, they like bringing it. So let's solve it. So you need to understand that if a function is even. Okay, first let me solve question 4.1. I'll show you with the question. So like the first question is that we've been given f of x, which is equal to square root 2 minus x power 2. Okay, so if a function is even, it means that the original function should be equal to, when we substitute what is x with negative x, whatever you get should be equal to the initial function. So the initial function is 2 minus x power 2 is equal to, so it should be equal to what we'll get when we substitute x with negative x, so which is 2 minus, so this statement you have to write it, this part you can write a statement here that if a function is even, yeah, then you start solving now. So what is x? I'm putting negative x power 2, right? On this side I'm going to have this, but when I simplify the right hand side, minus, so what do we get when you raise a negative to the power of 2? We get a positive, right? Power 2. So this means that the function is even. Okay, so let's try to see if maybe there are possibilities of it being odd. So we can conclude that since we can write a statement that since this is equal to this, as shown above, it means that it is even. So if maybe you wanted to see if it is odd, so if it is odd, it means that when you substitute what is x with negative x, what you get should be equal to, when you multiply the whole function with what? When you multiply the whole function with a negative, the whole original function, when you multiply it with negative, so should be equal to, so this is the negative here. So the function that we got after substituting x with negative x was this one, right? So we start from here. So when we substitute x with negative x, we simply get 2 minus x power 2, right? And then when we multiply the original function with the negative, this is for odd, okay? For even, we found out that it is even, right? Okay, so we are simply going to get, now is what I'm having here similar to what I'm having here? No, because this one is having a negative in front, right? So always know that if you just find that the first one is even, just know that it can't be odd. Like there are no situations, even if they are rare, but I've never encountered a situation whereby a function was both even or odd. I mean both even and odd. It can only be one or none. It can happen that it is just even, or it is just odd, or it is neither even nor odd. So look, if you find that it is not even, what is here and here they are not matching, you can proceed to find if it is odd. Okay, but if you just find, like, first try on this first step here, you find that it is even, you don't necessarily have to show that the odd part, because it can't be odd if it is even. Unless your lecturer is strict, you can show both cases. Okay, but what the majority do is that if they find that it is even, they will just conclude there that this is even, because it can only be one. But if after you find again that it is not even or odd, you can simply conclude that it is neither even nor odd. If you remember in English, they taught you that that either goes with what? Goes with or, right? It's either it is even or odd. Either goes with or, but neither goes with no. Remember these vocabularies. So when you're concluding, even though math they don't really consider the English, but at least try to show them that you got some, I mean you understood English in grade 12, especially you guys who got distinctions. This is how you can prove to your lecturer that you had a distinction in math. Anyways, I'm just joking, but yeah, just a reminder, guys. though some lecturers can't be strict on this. Yeah, so let's go on the second question. So the second one, so likewise, if it is this, let's see if it is odd. If it is odd, it means that this condition is going to be met. So the original function, so where is x, substitute negative x. So it's going to be 1 minus negative x to the power of 4. So now, you need to know that whenever we raise negative to an even exponent, or to a number that can be divisible by 2 without leaving a remainder, like 4, the negative will be cancelled. Okay, so I'm going to get a positive. So the negative will be cancelled. So we can conclude that this is even. Okay, but if your lecturer is strict enough, you can proceed and show them that it is not odd. Okay, and how do you show that? You do that by saying if it is odd, it means that this condition is true. This is known that it is this one here, right? So we start from here. Then when we multiply the whole expression with a negative, and I'm going to get negative 1 plus x power 4. Okay, let's go to question 3. So question 3, I hope you are getting the concept. So question 3, they have given you a function which is f of x, 3x power 3 plus 2x minus 1. So if this function is given, so if the function is given, it means that the original function should be equal to what we get when we substitute x with negative x. So let me write the original function, which is x power 3 plus 2x minus 1. Then while this x, I'm going to put negative x power 3 plus 2 negative x minus 1. Right? So here I'll get 3x power 3 plus 2x minus 1 equal to. So when I raise this one, the one that's raised to the power of 3, when I raise it, when I raise a negative to an odd exponent, or a number that cannot be, that can be divisible by 2, but it will give us a remainder, we get a negative. So I have negative in front, x power 3. And here I have negative 2, x minus 1. Now, is what I'm having on the left side equal to what I'm having on the right side? No, right? So this is, of course, not even. So if it is not even now, don't end here, proceed. Let's try to find if maybe it is odd. So if it is odd, it meaning that minus 2x minus 1. Let me write a statement. So if it is odd, it means that what I get when I substitute x with negative x should be equal to what I get when I multiply the whole given original function throughout with a negative. Right? So what am I getting when I substitute x with negative x? I'm getting what I'm having here, which is negative 3x power 3 minus 2x minus 1. So what do I get when I multiply a negative throughout the original function? If I multiply throughout the original function, so I'm having 2x minus 1, so negative 3x power 2 minus 2x plus 1. Right? So again, this is not even odd. So it is not odd. So now you're going to conclude that, okay, I've tested to see if it is even, but it's not even, and I've tried to see if it is odd, but it is not odd. So it is none, right? Like it's neither even nor odd. So you say it is neither even nor odd. So if your tutor will write if it's neither even or odd, if your tutor don't put or, because I said neither goes with no, right? It does know that tutor of yours didn't get a distinction in English, probably maybe a 3, 4, or maybe even a GCE. This is how you'll be knowing. Okay, so the day your tutor will be teaching you this, you observe how your tutor will write it. If your tutor will put O when we are having neither, just know that one didn't get a distinction in English. Probably even LA, that one just cleared with a C. Anyways, I'm just joking, guys. So let's proceed. Alright, so let's try to find if this one is even. So if it is even, it means that the original function should be equal to what you get when you substitute x with negative x. And I think this one should be your homework. You who's watching this, I want you to try this out. And just comment in the comment section there. Put a comment. So put a comment in yeah. So comment. You need to comment if question 4. Just comment like this. You need to comment that 4. Then make sure that you type this. Then you tell me what you're going to find. If you find that it is even or it is odd. I think let me give you a tip. Or should I solve it? Okay, look. So this one, the way you're going to approach it is that you're going to make it a single fraction. Okay, so look, you have x plus 1 over. So for you to solve it easily, so then you say, I think I'll just solve it. You know, most of you guys are just problematic. Okay, so I'll give you, but I think an homework. Okay, I'll give you an homework which I won't solve as we are going. Maybe on question 5, I'll see a question. All right. So you see 1 into this, it is x, that is x power 2. That will be plus 1. Okay, so I'll be dealing with this one, the one which is a single fraction. So I'll say if it is even, should be equal to what I'll get when I put negative x where this x over negative x where this x. Right, so I'm going to have, this will give me positive, right? So I'll just have this one, then here I'll have something like this. So now look, actually this will be a negative. So this is not even, because the one that's on the right side, it is having a negative. And I mean on the denominator part. So let's try to see if it is odd. So if it is odd, it means that what I'll get when I put negative x where this x should be equal to what I'll get when I multiply the original function with a negative throughout. So when I substituted when I substituted x with negative x, I got what? I got x power 2 plus 1, right? And then over negative x. What if I multiply the original function, which is this one I've simplified here, into a single fraction? I multiply it throughout by a negative. And what am I going to get? Negative x plus 1 over, no, just over x. Yeah, now, is what I'm having on the left side equal to what I'm having on the, what have I just written? So this would be negative here. Yeah. So am I getting the same things? No. So this also is neither, neither even nor odd. Now you have to write properly, not the way I'm writing. Even me when I'm, I have this bad handwriting which I usually use when I'm solving. It's very terrible. But when I'm solving like for my lecture, I make sure that at least, I know my handwriting is not neat, but I try to make it neat and visible. Not as if you're a doctor. No. Alright, so question 5 is saying that if the function, this function here, and this function function f and function g. Find g of f and f of g and determine its domain. So you find this one and this one, then determine their domains. And then this one is saying that if this function f is given like this, then the function g is this one. Find f of g and determine its domain. Simple, right? And question C, they are saying that if this function and this function they have given you, find f of g and determine its domain. This should be the simplest question. Like, we've solved a lot of, I don't know why they have brought these types of question again. Like, we've solved a lot of them. Question D, they are saying that if function, this function here and this function here, they have been given you, find g of f and f of g. Come on. I think I won't solve all these questions. Like, I've solved a lot of these, so I'm going to solve some. Some I'll give you as an homework. You also try some. But I'll try my best, I think, to solve like them. I think I'll just leave one for you. You'll give me, yeah, I'll give one. I think I'll give you like 2 since there are 4. Okay, I'll just see the simplest one. Maybe, I think, yeah, okay, I'll just see. Maybe this one. Yeah, I'll give you as an homework. You also try, then you put your answers in the comments. You need to participate. For you to enjoy, you need to participate. So let me solve this question real quick, and make sure that you subscribe to A+ Academy. If you haven't, trust me, you are missing a lot. That's why I solve, like, the way I'm solving this video. That's how I do, like, on every topic. I do that. That's not only in math, but also in physics, chemistry. Okay, even in math especially. What I'm just giving you in the video, it's just 20% of what is there on the A+ Academy app. On A+ Academy app, you find 4 video lessons, not just focused on solving, but teaching and solving, all of them combined. Now, I mix solving in the video lessons, whereby if I teach, then I solve tutorial sheet questions. If you've seen the videos there, you find maybe a video titled Solving Tutorial Sheet Question. On every topic, I solve. That's what I do, I solve. And then I also solve for you tutorial sheets. Like, for you guys who just want to revise quickly, you find handwritten solutions. Okay, not just solving, but I also explain more solving by writing explanations. So make sure that you contact me. I'll put the contact maybe on the screen, maybe at the end of this video. So let's proceed and solve. Okay, and subscribe to this YouTube channel. Make sure that you subscribe. I repeat, subscribe. So let's solve.
Hi everyone, I'm ma110 Naomi, a former A+ Academy student, and I want to share how A+ Academy completely changed my learning journey. Before joining, studying felt so overwhelming, but A+ Academy made everything clear, simple, and easy to follow. What makes A+ Academy to stand out is how effective the teaching style is. To start with, it uses Telegram and also A+ Academy app, which you can download on Play Store. On these platforms, there are videos, well-explained videos, solved story sheets, solved exam papers, solved test papers, and also pamphlets for ma110, which involves answered test papers. There are 4 courses that are taught on these platforms, unlike other tutors who only offer 3 courses. So the courses that are taught are PH110, MA110, CH110, and also BI110. So it was all because of A+ Academy's help that I managed to get A pluses in all the 4 courses that are offered. I'm pretty sure that if it was offering CS110, LA111, I could have gotten A pluses too. So you can also take a look at my results on the screen that I'm genuinely proud of, and I highly recommend all of you doing non-quota to join the only affordable and best tutorial in school. Thank you.
Alright, so question 5a. If f of x, they have given you f of x, it is x power 2, and then they have given you g of x, which is 3x minus 4. So the first one they want you to find is g of f of x. So meaning that get the function g, where this x, put the whole function f. So it's going to be 3 x power 2 minus 4, so it will be 3x. Now they have also said that what? They have also said find the domain. Now remember, we have a quadratic function. The domain for a quadratic function will always be negative infinity to positive infinity. Like all possible values that can be x can be any, or if you want you can say all real numbers. Okay, so you are done. So let's go to f of g of x. So meaning that why this f, in the function f, why this x, put the whole function g, which is this function right here. So the whole function, so I would say, so the whole function, so why this x here, I'm putting this whole function, which is 3x minus 4 power 2, right? So maybe to just show some efforts, try to expand it. So expand this function. So it will be, let me show you the shortcut of expanding. You can expand using the method that you know. So the easiest way to expand is raise this to the power of 2, which is going to be 9x power 2, and then raise this to the power of 2, that will be plus 16. Then say 2 times this one times this one. I'm showing you the short method. So 2 times 3x, 2 times 3x, that is what? You look, this method you only use it if it is raised to the power of 2, okay? This short method. So 2 times 3x is 6x, right? 6x times negative 4, that will be, it will be negative 24x. So we finally have, so this method is what I use usually when I'm solving a tutorial sheet. You will not see me showing how I'm expanding this. I'll just see it in my head, like, okay, so that's how you easily expand. If you don't want to follow that method of this times this, this times this, this times this, that method, you can just see this to the power of 2, this to the plus this to the power of 2, plus this times this times this. Yeah, so I've showed you a trick. And if you want to know more mathematical tricks, make sure that you subscribe to A+ Academy app, because that's where you find video lessons where I show everything that I know. I show all the tricks that you can use to solve different questions. Right? So now what's the domain for this one? Even this one, since it's a quadratic function, domain will be this, right? All values of x can be any real number. Right? So let's proceed. It's got to b. So b, they're saying they have given you the function f of x, which is square root of x, and g of x. Alright, then g of x has been given to be 2x minus 1, right? So we want you to find f of g. So meaning that get the function f, where is x, put this whole function g. So this is f of g. So now for you to find the domain, you get what is under the square root. Say it is greater than or equal to 0. Then take this on the other side, over 2 over 2. So x is greater than or equal to 1 over 2, right? So we can write this in intervals if you want. You can simply say, since it's greater than or equal to here, it's going to be starting from 1 over 2 to positive infinity. Alright, so let's say they've given you f of x that is equal to 2 x minus 1, then now g of x is equal to 1 over x. So they want you to find f of g. So get a function f, then write this x, put this whole thing. Okay, so we say 2 over, write this x, put 1 over x minus 1. So we are getting, I think I was supposed to give you an equation, guys. I'm supposed to give you an homework. I think I'll make the last one the homework for you. I want you to comment in the comment section there. Right. So the easiest way to solve this is to say 2 divide by 1 over x minus 1. Then this one here, we just solve it this into this, it's 1 minus x, right? So basically we are having 2 divided by 1 minus x over x. So it's going to be 2 times x over 1 minus x. That's going to be 2x over 1 minus x. So which is we've just found our f of g. So for us now to find the domain, we're just going to get the denominator and equate it to 0, because the denominator cannot be equal to 0. So we can just take x here. So x should not be equal to 1. So we can conclude by saying x can be any real number, but it should not be equal to 1. That's how you go about this. Right? So now, let me see. But I really have to give you an homework. Now the last one again is involving, the majority of you will be stuck, you'll be like, just solve it. Okay, let me just solve it. So, but I'll give you an homework. So, I'll give you like an exercise. You just comment there in the comment section. So D, they are saying that if f of x is equal to this function, g of x is equal to this function, find g of x and f of g, then determine their domains. Right? Alright. So let's begin by finding our right, so g of x, let's begin by finding g of x. So to find g of x, in the function of g, where there's x, substitute what? Substitute this whole function here. So we're going to say, where there's x here, I'll put this whole function, which is 1 minus x power 2. So this is my g of x. Now to find the domain, I'll get what is under the root and say it is greater than or equal to 0. How can I solve this? So I can solve this by doing this. I can take 1 on the other side, right? It's going to become negative 1. I don't need to have a negative here. Let me get rid of the negative over negative. Now remember, if you are dealing with the inequalities, whenever you divide a negative into what is on the right hand side, the sign here will change. We like doing these kind of tricky equations. As long as what you are dividing into the value that is on this side, it is a negative. Like this case, we are dividing negative 1 into the negative 1. Now, as long as what is here is a negative, the sign here will change. Of course, the negative will cancel, but the sign here will now become, have you seen? So the sign has changed now, less than or equal to. Alright, so we can now say we can now solve for x by simply introducing square roots on both sides. So x is going to become plus or minus. When we introduce the square root, plus or minus is introduced. The square root of 1 is 1. So if we're to find the critical points here, the critical points are going to be positive 1 or negative 1. Or x is equal to negative 1. Let's draw the sign table. I think in the tutorial sheet I made a mistake. Like I forgot to change this sign, which is a very big deal. Make sure that you change the sign. That's why I have recorded in the video. Because when I'm solving the tutorial sheet, I don't talk, like I'll be just thinking, and I might make some mistakes. Now it's very hard to make mistakes when I'm talking while solving. So it's very important that you watch the video. So here I'll put negative 1, here I'll put 1, and now here I'll put. So look, in this situation, the factors can be x minus 1 and x plus 1. You get the factors by taking this on the other side and taking this negative 1 on the other side. You are going to end with two values, x plus 1 and x minus 1. So here I'll put x minus 1, then here I'll put x plus 1. So here they can be negative 2, here they can be 0, here they can be 5. So I put negative 2 here, I'll get a negative 2, negative, so I'll have positive here. If I put 0, I'll get negative, positive, negative. 5, if I put 5, I'll end up with a positive, positive, positive. Now, since I'm having a less than or equal to symbol, it will mean that I'm looking for the negative region, this region here. So the domain is between negative 1 and 1. So you can simply say the domain is between negative 1 and 1. And you can prove this. Let's use this one to test. If I get negative 2, I put it here. Am I going to get a value that is greater than or equal to 0? If I put negative 2 here, I'm going to get what? Negative 4. And if I say plus 1, I'm going to get a negative. A negative is not greater than 0, it is less than 0. So anything that is in this region, it is not true. But if I get 0 and I put it here, I'll have 1. 1 is greater than 0, so it's making sense. But if I get 5 and I put it here, same thing, right? I want to get a value that will be greater than or equal to 0, but I'll get the one that will be less than 0 because it is going to be a negative. Makes sense, right? Yes, so this is the true domain. Okay, let me continue from here. I think for you guys, YouTubers, you guys on YouTube, this is the end. Like, this is the last question I'm solving for you guys. Unfortunately, yeah. But for you guys who are subscribed to A+ Academy, I'm finishing this tutorial sheet, right? So if you want to access the full video, just subscribe to A+ Academy. I'll put my number on the screen. You'll find the videos, not just the video for this, but the video, many videos that will be very helpful for you. So make sure that you subscribe to A+ Academy app. You'll find the full video, the part 2 video where I'll finish. So far I've only found g of f. Now let me find f of g. F of g. So I'll get the function f. Where this x, I'll put this. So it's going to be I've gotten the function. What am I writing? Okay, look, we get the function f, so I'll say 1 minus, then where this x, I'll put the whole function g. Then we raise to the power of 2. I just like doing this. So you have 1 minus. Now when you raise a square root to the power of 2, the square root get cancelled. Okay, so I'm now going to have 1 minus x, but this is a linear function, and the domain for a linear function is, or if you want you can say, the possible value of x for this function can be any real number. Alright, I think for you guys on YouTube, this is the last question we are solving for you. So question 6, 7, 8, 9, 10, 11. So question 6, with one, find the conditions on it, what that guarantee of these questions. All these questions, this question, and I think there's also a question, after question 11. So these questions are going to be solved in part 2 video, which will be on the A Plus Academy app. I'm pretty sure it's also going to be quite long, but not that much, but I'll try to keep it short. But but it's going to have content, a lot of knowledge will be shared. So make sure that you download the A Plus Academy app. I hope that you've enjoyed. Even though some of you wouldn't even want to subscribe to the app, but I hope that you will still benefit. You have benefited from the YouTube video. Even the YouTube videos are beneficial, right? It's just that the full content is on the A Plus Academy app. So make sure that you contact me to access the A Plus Academy app, then access the part 2 video for this lesson. Hope that you've enjoyed. But even though you don't have access to part 2, but make sure that you subscribe to the channel. Subscribe, because I'll be posting videos like this, and I'm pretty sure you've benefited from this video. See you in the next lesson. Plus app. This is where you access all the full videos. So what you just do is come here on videos, and then click on term 1, term 2, or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions. If you haven't understood everything that we've learned so far, that we're going to cover in the video. Okay, so all these topics, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are. Then you catch up at the end of the day. And we have a lot of students who are watching these videos, and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. You're going to find videos about it. Okay, but it's not only math. Even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just use CH110. You find the videos here. Okay, if it's introduction to chemistry, you find the videos. So all these topics have been taught. Alright, so it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A Plus Academy app and start learning and practicing with our solved materials.